Good day, sir. My name is Rojin Hare, and I will be doing the demonstration for the programming project of Group 11. Before I start the demo, uh, I'm going to show you how to run the program and how to show the result of the Lagrange calculations and how it is applied to the program. Now, first, you have to copy this and then where paste it to the movements. So where every time it moves, it should be there every time the player moves, so it prints in the terminal. Now to run the program, you have to drag the folder into VS Code, and you need to have Pygame installed. Or I've included an executable file which you can use just to make things easier, so you won't have to worry about installing Pygame. Now, when you click Run, the game brings you to the title screen, which is the main menu. If you click Exit, it's going to terminate the application. If you click Start, it leads you to the difficulty selection screen. Now, the difficulty is linked to the gravity constant. Now, the gravity constant is used to make the result of the Lagrange interpolation less potent. If I don't add a gravity constant, what's going to end up happening is that the player model is going to keep getting pulled to the bottom right corner of the screen. Adding this makes the result less potent because the gravity is directly tied to the velocity of the snake. The higher value it is, the more potent it will become, which is why you see for hard, I made this the value. And for easy, of course, since it's easy, I have to make it lower. To show you the gameplay, I'm gonna play in easy first. Now, the gameplay loop is pretty simple. You just have to collect points, and as you keep collecting points, the game gets harder because you get more data points, and the number of obstacles increase. If I get to 20 points, the number of debris will increase. Now, the debris, what that does is if the player collides with the debris, uh, a point gets deducted. If the point, if the total score gets below 0, it will lead you to the game over screen. As you see, I reached 20, so now there are more. If I reach 25, there's gonna be more obstacles that pop up, like this. This is the game over screen. But before I explain this part, I'm going to show you that when when my score reaches 30, the amount of stars increase, so more source of points. It allows you to progress through the game faster. Now, the stars and the player model serve as the data points that I use for the Lagrange interpolation function. As you can see in the terminal, this is the data points that I'm using for the Lagrange form. Now, there are two others that come out in the terminal, which is the result of the Lagrange interpolation, and below that is the applied gravity. So that's after the Lagrange result is multiplied to the gravity constant, which is tied to the difficulty. Now, if I get to 30 points, see, there's three additional data points were added, and it's gonna keep doing this every time I get 30 points. So as the game continues to run, more data points will be added, as such. Now, when I collide with an obstacle, the game immediately finishes. And if I collect a piece of debris while I have no points, the game ends. Now, if I go to the main menu and click hard, as you can see, I'm being constantly pulled to the top. If I collect a data point, I can freely move. But if I take too long to collect another one, it will become more unstable. Now, as the game progresses and more data points are added, I would need to be quicker and get the stars before I lose control. And that's basically it for the game. It's relatively simple. And for yeah, click retry is it's gonna lead you back to this with the same difficulty that you set beforehand. If you click main menu, brings you here. And if you click exit, wait, if I just, it's an obstacle. As you see, it's hard to control if you don't get, if you don't get enough stars. Now, if you click exit, the whole application is terminated. And that should be all for the demonstration. Thank you, sir.